power, low noise power, whether it's an EV charging station that needs dispatchability and, low footprint, or the military that needs low maintenance and fuel flexibility. We're excited that we get to actually offer the full breadth of value that our system can provide. And, I think right now that excitement and novelty is truly what's, driving the customer experience right now.
Thanks, Jake. I have to say, five Californias still has me reeling here, like because I think
Right.
California is what the fifth largest economy in the world, and five of those. That's pretty amazing,
Exactly. Yeah.
incredible stuff. So Jake, Davis, Kevin. Thank you, Jake and Davis and Kevin. You go next. What are your thoughts on this? What is it like to work with customers at this time?
Yeah, I would definitely pair it novelty, and there's kind of a frenetic energy in the industry for sure. Given these issues that you've highlighted well, the need for power, the constraints on power, the need for high reliability. And so we see a lot of customers that, it's good to have Jake here from Hyliion as an OEM producer of energy, as an infrastructure provider, Siemens, is more in the turning that energy into a useful form and transmitting it. So the local distribution grid. But it means that we see a lot of customers that, yeah, are looking for full approaches, both technology wise and, even development, like from the development perspective, from a funding perspective, customers that are doing things that are very different than what they've traditionally done or just been used to. And between the various industries that, we come across, I'd say that you have, a huge uptake in the demand of power from data centers, certainly. And it's meant that a lot of, customers like manufacturers that, traditionally might be, as you said, yeah, really, really desirable customers from utilities, well served, are getting a little bit left behind. And so it's an interesting place where they are feeling the same, sort of I guess the follow-on issues from the explosive load growth in data centers, and they're having to become more sophisticated themselves and advocate for things that they need. And increasingly for us, that's a lot of on-site generation, that's a lot of power controls, that's a lot of islanding capable devices and devices that are more dispatchable or more curtailable. And yeah, all of it is meant it's a really, as you said, interesting time, exciting time to be in the industry.
That's fascinating. It's kind of, it sounds like it's forcing customers to really think in novel ways and learn a lot more about energy, which is a good thing. We've always wanted that, haven't we? Kevin, I'm curious what you think about this. What are you finding with
Well, a
customers
lot of
at this
this,
time?
a lot of the same things that Jake and Davis said. We've always tried to position ourselves to be trusted advisors for our customers, and they've relied on us for years. But to some great points made earlier about they're really having to, come to grips with the fact that they're going to do more advocacy for themselves as they look for to grow their business. Power is going to become a limiting factor. We're already seeing it in parts of the Midwest, which for years were blessed with really cheap and abundant power. So if you wanted to grow your manufacturing facility, it was easy to do. The utilities would run right out and bring you another feeder, and you're up and running. Nowadays, to your point earlier, customers being told it's no longer months, it's years for additional power for them to grow their existing facilities. So they're having to become a lot more sophisticated in their understanding of energy, how it's used, and what it costs, and the tariffs, and what they can do to kind of hedge their future energy costs through new technologies or existing technologies.
So Kevin, resilience has always been a hard thing to put a dollar value on. Are you
Absolutely.
finding that's changing as these customers sort of learn more about energy? Is it still a core challenge? Has it shifted?
It's still a challenge to quantify it because until you go through it more than once, it's hard to put a dollar amount to it to fully understand what it costs for commercial or industrial customers to be without power for any length of time. they can always estimate it, but until you go through it a couple times, you have that happen to truly appreciate it. But I will say that grid reliability is making these potentials more and more uh, likely to happen. Blackouts are happening more than ever because of weather events, even in the Midwest. So it's driving that point home that resiliency is important to customers, and because of the cost of power, it's given customers the opportunity to monetize those assets as well. So it's kind of a two-part solution. The first is resiliency, and then monetization by potentially using that asset for peaking or demand response programs.
Yeah, I'm glad you brought that up because I want to talk about stacking values. Davis, so everyone's talking about stacking values these days. I keep hearing the term, right? But in reality, we often see that the values can compete with each other, like carbon versus cost, right? How do you help customers navigate that?
Sure. Yeah, I think, Kevin framed it up really well, actually. The best thing to do, in my opinion, is to try and articulate how they're not in competition, how we can meet a resiliency goal while also producing value. And so, yeah, there's, a great wealth of demand response programs, or, getting customers to understand that maybe the flat rate tariff that they're on, that has just that dollar per kilowatt hour value for every kilowatt hour that they use, is maybe not the right rate schedule for them as they think about, adding distributed energy or curtailable loads. That, we should actually look at a time of use rate and layer that in with something like a demand response program. And now you can begin to see, okay, there's real value to this asset in addition to the resiliency that, yeah, is very, very hard to quantify. So that is, generally a productive route, but oftentimes you still wind up, with an asset that doesn't totally pay for itself, or you've treaded a territory that is maybe so new for a customer that they're really not with you in terms of, like understanding the value and understanding that this really could have an economic return. Um, and so in those contexts, it's just really important to be sure, like any customer, any sales process, you want to be sure you're engaging with the right stakeholders, the energy management team, at the site where you're talking about, being sure that you've engaged like with the actual people that manage the facility and understand the power quality issues and understand what an outage means, all the way to, right, the financial side, where those, the people that are funding it, that need to come up with the capital expenditure budget, um, are hearing from that same stakeholder right at the facility, that they can articulate now, okay, it really is worth it. And you bring in carbon to the picture too, understanding a customer's sustainability goals and pulling in that stakeholder as well, right? If they have a cost of carbon that they can actually articulate for you, that's incredible. That's pretty rare from my experience. But being able to get more buy-in, from that sort of individual to say that, okay, maybe the project doesn't total for us, but it's in line with these sustainability goals. It's in line with our carbon reduction targets. So it really is something we should do. And, we're willing to pay a little bit of a premium for that. That's typically how I would go about it.
Yeah, I'd like
It's
to
really,
add a
yeah,
little color there, Elisa, as well. I think Davis made a good point on, the value that these assets can potentially create as well. What we're seeing at Hyliion is definitely a shift, and maybe this even goes back to the previous question, in that resiliency used to be this pure insurance play. How do I mitigate my downside? The asset, the ROI on the asset with a relatively reliable grid, isn't really going to pay back. And so what we're seeing is that, with these new cost and availability constraints, is customers are coming to, companies like ours and asking, how can I also create value and create upside with the asset rather than just mitigate my downside? And, a great example of this is a customer recently, I've been working with out west that They have a lot of cold storage, and so during grid outages, they lose inventory due to spoilage. And so what they did to solve that problem is they put a diesel generator in, as a pure insurance play to prevent that loss. But now their diesel generator is due for replacement. And they also want to expand their facility to generate revenue and create value. And so what they're looking at our system for is not only mitigating their downside, but also increasing that upside and adding value to their site, in addition to just the backup power play. And so that's where we're kind of seeing the conversation go as well. It's these assets getting deployed, due to the environment we're in, are more trying to create upside and use resiliency as kind of a benefit of doing that.
Interesting.
Yeah.
So resilience as more than just an insurance policy. It's resilience plus.
Right. Exactly.
Yeah, that's a good way to frame it too. It's part of, it's only a product of some of these new technologies, right? The linear generators are a great example. Battery energy storage is a great example where companies are seeing that backup diesel, that emergency diesel that sits there and has high maintenance costs and is really dirty when it does run. And they're like, man, I'd love to get rid of that. And maybe I should look at some new technology that could do a lot more for me than just power the most critical infrastructure during a grid outage. And so I'd say a whole host of customers are looking and asking those sort of questions, which is awesome to see.
Fantastic. So Kevin, I want to jump to you. I'm curious. So I think when you show a customer a model, they often ask about day two risks, right? How do you use modeling to de-risk the uncertainty of a 10-year fuel price volatility or changing utility tariff?
Oh,
What's the
great
approach?
question. But yeah, knowledge is the key to these conversations, and having a tool like Xendee. No, it sounds like a commercial, but this is kind of what we're here to discuss, right? Having a tool that you can drill down into details. And as you can tell by my beard, I've been around in the business for several decades, and it's one thing for me to say, you know, trust me, this is going to work out great for you. We've done hundreds of installations like this, and it's another thing to have detailed financial reports that takes into account, the 15-minute utility interval data layered in with their tariff rates and their time of use rates, and detailed financial reports that you can walk into the C-suite and put in front of them. They feel confident with that type of information is critical for these types of projects, because they're $1 million or multi-million-dollar projects with life cycles that are easily 10, 20 years. So it's 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 important, especially when you're dealing with customers who their primary business is not power generation. And if they really had their choice, they want to do it in the first place. The market is pushing them, and the cost of energy is and grid and reliability on the grid is pushing them to have to take on that risk of ownership themselves, because they prefer not to. They'd rather invest in new, production equipment for something that they understand and that their business is built around. So having this type of information that we get through your system is critical to have those very, direct conversations that involve, ROI and how many hours are going to run in the operations, and having real detailed cost analysis.
Yeah, and the word I'm hearing more and more these days is speed. In fact, I hear it several times a day, it seems, right? Speed
Speed
to
to power.
power,
Speed to
speed
power.
to
Speed to
power.
power.
Yeah. So,
It's something.
so I'm curious, and this is
Yep.
a question for all of you, but I'd like to start with Davis. So if the real metric is time to revenue, if the grid says 3 years, right, and the microgrid says, hey, 12 months, does that speed premium now outweigh the resilience premium? Is it more valuable these days?
In a word, yes, absolutely. I mean, speed, in particular for data center customers, where you're seeing so much activity in other sectors that either support data centers, so semiconductor manufacturing, that's caught those tailwinds. And yeah, the speed requirement or desire from these customers is tremendous. It's kind of, unlike anything I think the industry, the electrical industry has seen before. And so, yeah, that need to get power on site, as soon as possible, sometimes in frankly, like pretty unrealistic timeframes. We see, time and time again. And so it becomes a role of, I'd probably say all three of us here to, be realistic with our customers in terms of what technology is available, when it's available, at what scale. And, the good news is we see a lot of customers too that, you hear about the 1 gigawatt, data center project or something. But what's behind that is it's not 1 gigawatt, all at once, right? It's a phased construction project. And in those ways, we can really customers, setting up something like a master supply agreement where we have a set bill of material that we build in chunks. We build it in, 30, 50 megawatt chunks, and we set up the supply chains, help those customers. They can project much more concretely. Working directly with an OEM like Siemens, you can know that you're going to be able to get your next 50 megawatts on schedule and phase in and build the infrastructure quickly still. But we have, I guess, a job to do to be realistic with like what speed is really possible in a very constrained environment.
Yeah, speed to power has turned the traditional, um, it's an engineering problem in a way where we're trying to solve for our customers is an engineering problem. They require a certain amount of power for their facility, regardless of what type it is. And it's kind of turned that on its head where in the past you'd have meetings to discuss, how much power they needed, what they were doing with it, and have a discussion about what's the best technology and what's the right size and combination of equipment and and then cost. And now it's kind of flipped on its head where the conversation starts with how fast can we get, to Davis's point, how fast can we get 50 megawatts? And then a discussion of the technology and whether or not it'll fit. We're seeing a lot of decisions that wouldn't traditionally be made just because of availability of certain products. Um, so it's kind of turned it on its head. I can see Jake is about to talk, so I'll stop and give him a chance to join in. Sorry, Jake, I probably stepped right in
No,
front of
no, totally fine. I agree with what both of them are saying. I think, anytime you compare speed to resilience right now, speed is going to win. It's the path to revenue and the value created there is going to vastly outweigh, the downside mitigation from resilience. But, the pushback I kind of have here is I don't necessarily know that these are completely competing premiums here. So the same microgrid that gets you to gets you to revenue faster, is also the one that's going to deliver your resilience, right? In most cases. So an example of that is a EV charging customer I've been talking to that, they basically told me they've gotten into the power generation business when their actual core business is infrastructure for autonomous vehicles and, the new EV semis. But the reason they're doing that is because the grid is 3 to 5 years away. And so they have to stand up these microgrids to get them to grid power. And then once grid power is available, they switch this microgrid into more of a supplemental mode where it's, either cost down or, resilience, for the overall site. And so the point I'm making here is that, that one microgrid is serving both functions, both resilience and speed. And, the thought of the resilience there is that speed gets you to revenue, gets you to market, and resilience keeps you there. So that's how I kind of think about that.
So they work more hand in hand than one trumping the other right now.
Right.
Yeah, interesting.
when
Very
done
interesting.
properly. To Jake's point, when you do it properly and have those
Mhm.
conversations, yes.
Right.
Yeah, yeah. So let's talk a little bit more about customer psychology and resistance. What I love about this panel is you are all bringing a different perspective. And, Jake, you're walking in with a brand new technology. Davis, you're walking in with Siemens on your badge. And, it's a company that's been around for a long time. How different is the resistance you face regarding maintenance and long-term reliability? And Jake, I'll start with you and then let's jump over to Davis.
Absolutely. Yeah, so obviously, as a new technology, I would imagine that the conversations we're having now, I can't speak for the conversations Davis is having, but I can imagine that those discussions are very different. We spend a lot of time educating customers on, how our system works, why it's low maintenance, why it's long life. But what I'll tell you from a customer perspective is that these traditional technologies like natural gas generators, diesel generators, they've set a really high standard in the market already for decades on how service should be conducted and the lifetime of a generating asset. So the expectation from a customer is that a technology like ours coming into the market can at least meet that standard, or else we don't even get in the door, right? Now, what I'll say on the conversation, about new technology and the pushback you get from a customer, I think that's actually not an insurmountable discussion. And, if you look at the work we've been doing, clearly that's evidenced by some of the work we're doing with the Navy and DARPA, basically powering the first unmanned vessels for the US Navy. And if you look at that specific application, that's about as high risk for a new technology as you can get. There's no life support systems on this vessel. There's no one there to turn wrenches. And so if you don't have a long life, low maintenance system, you don't have a mission viable vehicle, right? And so, the way we go about educating our customers and getting them on board, since we're new technology, is step one, we get them very familiar with how our system works and the architecture of how we're low maintenance. So things like our hermetic sealing, no combustion, the frictionless piston design so you don't have wear parts, and so forth. And from there, we then move into testing and educating them on the data that we're collecting on our system. And then third, we say, don't take us at face value. Let us deploy our system in a small scale in your application, and then scale up from there. And so, obviously going to be a different conversation than one Davis is probably having, but something that we've learned to navigate.
Davis, tell us about your conversations.
Yeah, it's interesting. Of the people at Siemens, I'm kind of ask because certainly the existing, Siemens lines and the majority of the equipment we sell is incredibly rigorously tested, product lines that have been around for decades and extremely established technology with very clear processes and Jake's right, like by and large that stuff doesn't really get questioned in terms of its reliability. It's really established. And as a partner, I think Siemens has positioned ourselves like really well in terms of the reliability of the equipment that we make. But my role in particular, as part of the sustainability group within medium voltage business, means that I do touch a lot of new technologies. So the linear generators and the battery storage and the fuel cells. And while we're not producing any of that equipment, it is part of my role to really investigate how reliable they are. And for us, it's a lot about not the reliability of the individual component, like the generator, but the reliability of the system, right? So thinking about how power delivery is redundant, that we have eliminated single points of failure. So thinking about the controls system that surrounds those generators and the relays that are included as parts of switchgear, um, getting the right telemetry from the utility, and looking at power quality issues at a very granular level, like all of that is very much within in scope. And so those are more the issues that we tackle, where we're trying to be sure that at the system level, we've established really high, uptime and reliability, and then of course maintenance plan for that meets, the customer's goal for that asset's operational life.
So while you're here, Davis, while you have the floor, I want to ask you about the chocolate factory problem, the story you told me. Um, I feel like it illustrates, this problem of people not thinking about resilience until after they have a power outage. How do you get customers? First, tell us the story, and then tell us how do you get customers
Sure.
to think about resiliency in advance?
Yeah. Yeah. So the chocolate factory problem was, and actually this is an example of a good customer where they understood the issue they were going to have. Imagine this chocolate factory where they're producing, chocolate at a very large industrial scale, and they literally have pipelines going through the facility that have molten chocolate in the pipes. And it requires the facility to be operational and keep that hot, because if it cools and if it solidifies in the pipe, everything stops, right? You can't produce anything. And they have to come along with like literally a blowtorch and melt all the chocolate across this line. And it was something that they knew was like totally operationally disastrous. And so for them, it was a really clear value to resiliency, right? To be able to say, okay, like what is the actual productivity lost if this happens? How many man hours? How much supply, like quantity of your product? What is that worth? And for them, it was extremely easy to articulate and walk through like why a microgrid, why on-site generation really made sense for them. It's a site in California where the grid outage issues were really creeping up on them. And they knew, in particular with some of the like PSPS events, they knew that they could know when they were coming, but they didn't have a way to adjust what they were doing necessarily. So that was a good customer experience. The customers that are more challenging are the ones that don't have that clear, if the operation shut down, what is lost. Maybe they have an idea of the base critical infrastructure that has to stay online, things like, the IT for cybersecurity. Um, but this, that's the counter, the typical scenario where you really do have to work very hard with a customer to make sure that you've captured value of resiliency for them. And yeah, I'd be curious for Jake or Kevin's experience, working through that issue. It's quite challenging.
Yeah, it's super challenging to quantify that. The most challenging part is um, putting a dollar amount to it so they can, because when it's strictly a conversation about resiliency, it's what's the cost of being without power, right? So it's going back to Lisa, your point earlier about stacking value on top of it, making it more than just about resiliency to make it beneficial and walking a customer through almost like putting them on a therapy couch and talking about the problem and then what blow torches? That sounds does OSHA approve that? That sounds risky. What happens if somebody drops one of those blow torches? Is that going to cause me, like you're talking about it to me and that sounds archaic to me. So it's really just again about being an advocate and a trusted advisor for your customer and working through these different scenarios. And I mean, to answer your question about push resistance, I guess ours is a little bit different because we are an established technology and we can put warranty on equipment until it's 25 years old, which is longer than anyone who's involved in the project is probably going to even be at the facility. But some of the pushback we get is about carbon reduction. And as we're installing these mostly natural gas gensets for these projects nowadays, what's next for carbon reduction? So we are looking at different carbon capture technologies. We've got some side projects going with that to see what happens there. But also, Caterpillar made a huge investment uh, in hydrogen. So our generators, even units that are already in the field, can run on a hydrogen blend, today with very little modification and can be converted to run on 100% hydrogen in the future when or if that becomes available. So it's taking a, um, you know, your bridge power talked about a lot right now too, like bridge to grid, taking a bridge to grid technology and reeling it being a bridge, to future technology and future fuels also, so you don't end up with a stranded asset. So that's part of that conversation with the customers about how does it help you today? How is it going to help you, 10 years from now as change continues to happen at a faster and faster pace.
Multiple bridges to consider.
Right. Yeah.
The other thing I want to ask you about, Kevin, is that, it seems like data centers are just sucking all of the oxygen out of the room these days when it comes to energy discussions. And it used to be that we were focusing on in these kind of conversations, the commercial and industrial customers, right?
Yep.
It seems like they've been kind of pushed to the back of the line, at least in terms of discussion and maybe even practically. So tell me what that means. If I'm a manufacturer right now, I want to expand. What do I face?
Oh, a lot of challenges because it's to your point, the data centers are sucking the oxygen out of the room, and through the entire supply chain. So they're driving up costs on anything associated with power generation, whether it's switchgear, transformers, generators, cable, wire, steel for buildings, even as the cost is being driven up because of the demand. So it's challenging. But as a CNI customer, we established separate business groups to maintain focus on those customers because they were key to our business before the data center. Whether this is a boom, whether this is a bubble, they're gonna they're gonna be there when when this calms down, if it comes down. We'll see. Anyone's guess there. So we've got separate business teams and service teams established for our commercial industrial customers and make sure that we maintain the level of service and supply to them that that kind of put us on the map prior to the data center boom.
And this has all really changed kind of the utility customer and supplier relationship too, right?
Well, absolutely. Yeah. Our
Yeah.
utilities that once fought us, that employed teams to go out and find out if our customers are talking to us about on-site power generation or combined heat and power projects. We had a utility that I won't mention by name, but they had I wish you used to have a picture of it. They had like a banner over their office that said the cogen killers. And their
Oh my God.
their job was to go out and find, cogen projects that we were talking to customers about and make sure that um, the gas and electrical rates for that customer were structured so that those projects wouldn't happen, so um, they want to lose that base load, these smaller power generation projects in today's scale, to on-site power generation. So
Yeah,
Incredible.
and now they're referring customers to us and bringing them to us like partners.
Yeah, I'll even add to that, as a new technology on the block, several utilities interested in testing our technology to offer to their customers. I was even at a conference not too long ago, where the utility was saying, "Hey, we're planning on acquiring a very large fleet, over 300 megawatt fleet of generators to serve, markets that we're not going to be able to serve in the interim. Give us that bridge power." At specific sites. So yeah, I completely agree with Kevin. I think the utility model is definitely changing here.
So Jake, I want to ask you something. I've been curious about this. We talked a whole lot about over this last year. We've talked a lot about the One Big Beautiful Bill and how it affected solar. And your product, linear generators, actually did well in the bill with a 30% tax credit. How is that affecting your conversation with customers today?
Yeah, so just to kind of give the audience a brief background here. So when Section 48E ITC came out in 2025, we no longer qualified for the 30% tax credit under ITC because it wasn't a fully zero emissions project. And so what the One Big Beautiful Bill Act did is it carved out fuel cell technology as receiving that 30% benefit, and that's a flat. You can't stack benefits on top of that 30%. And then linear generators were specifically called out under that language as qualifying for the 30% credit. And so just to give the audience an idea of where that lands with the customer. So when we go deploy a unit to a site, the customer, they'll have their fixed costs, their CapEx that they have to, pay for both the equipment and the installation of the system. And both of those things have that 30% tax credit applied to it. So the equipment and the install, and the customer will get that back in a tax credit after year one of the project. And so the way the way we look at this is it's not the main driver of adoption for our technology. If you look at the operating side, where we have a higher efficiency, so a reduced fuel cost and a lower maintenance cost, we actually were penciling our projects, without ITC before this change. And so what we see it as is it's awesome to have because it's value add to our customers, and that's something we're really excited about. But it's a good thing for us, not the main driver of adoption. And so where I do think it could be really valuable is unlocking some of the applications that may be gated behind, lower spark spread areas where, most generating assets don't make sense. And, you find those all over the country. So overall, good case, makes it better. And it can even unlock some applications for us. But overall, we're excited about the value it offers our customers.
Very interesting. So Kevin, I want to jump back to you because you were talking a little bit about hydrogen earlier. And I'm curious, again, talking about customers, new technologies, how do they handle the gap between what feels like, hydrogen is out there in the future, or other fuels that feel like they're out there in the future, and where customers can actually act today? Kevin, are you still with us?
I think he's muted.
Sorry, hit the mute button one too many times. Yeah, the hydrogen has been around for a long time. We've used it in our generator, the high hydrogen fuels from like coke ovens or refinery gases for decades. So it's nothing really new to us, but making it available for other customers to store or pipe to a job site is still a ways off, but the equipment is capable today. And the most challenging part is the infrastructure involved. That's where we think it might be more reasonable to see like a 5%, 5 or 10% nitrogen blend into the natural gas pipeline here in the near future to help reduce the carbon content in natural gas, kind of spiking it like some countries do with propane during certain months during the winter. I think we're seeing that happen with hydrogen blends in Europe already. So like most good ideas, it starts in Europe and the US watches it for a long time and then we adopt it at some point. That'll probably happen, but it's still a very expensive fuel to produce and to store or to um, transmit through our pipelines. So there's a lot of challenges still out there for hydrogen. The equipment's ready, not just Caterpillar. I'd love to say we're the only company that does it, but you know, Siemens and probably Jake's company too look at it as well. It's if there's BTUs there, there's different technologies that can turn that into electricity.
Okay, so we have about 15 minutes left, and I want to leave some time for questions. So I want to ask two final questions of these great panelists. So one thing I'm curious about is, can a customer over-engineer for resilience, or what are the common ways they might do that? And can they end up killing their own ROI in doing that?
Yeah, happy to take this first here. So Kevin, in the multi-fuel conversation he's having right now, I think is a really interesting point. One area is a multi-fuel system that's coming to market where I see customers potentially overbuilding for resilience is using two different single fuel engines or systems for resilience. And a great example of that is a data customer we're working with where they have natural gas behind the meter generation. They have a single pipeline coming into that generation. And then, because the pipeline can't meet the data center's 5 nines uptime requirement, they have diesel backup at their site with diesel generators. So the overbuild here is that you could deploy a multi-fuel system like a Carno generator and run on natural gas. When that pipeline goes down, you simply have the diesel storage on site, switch over to diesel, and you reduce all of the capex of buying and installing those diesel generators. And so that's one area, and maybe it's a new field with a pretty niche use case, but that's one area where I see some overbuild.
Interesting. Davis, Kevin, do you want to jump in on
Yeah.
that?
I would
Yeah,
say I had very similar experience to what Jake described, yeah, where you have like a natural gas constraint and boy, you'd love it, get some more liquid fuel so people jump to like liquefied natural gas. But, you know, trucking that in is like really cost prohibitive and so yeah, it's a great solution and definitely something that we've looked at as well. Kevin?
yeah, similar, like different, existing technologies can do that, or whether it's combustion turbines that run primarily on natural gas that we're using a lot for data centers behind the meter projects that also can run on, like renewable diesel or other liquid fuels, or, also some larger recips can run on both, run on natural gas as the primary fuel source, and then switch over to, a liquid fuel during those emergencies. That's one way of, kind of over engineering, and then also, um, kind of just overbuilding to Jake's point earlier, um, especially when you deal with some of these bigger data centers and even industrial loads. They don't, when you're, when the project's first being built, a lot of times it's speculative of what equipment's going to go there, or what the loads are going to look like. And so you start building up, say it's a 20 megawatt, backup system. And, you know, then they start throwing in N plus one or N plus two. And depending on the primary mover, that could be, you know, can be a big additional cost. If you're running on one, 20 megawatt turbine, you want to go N plus one, that's a big investment. Or even if you're looking at, like 4 or 5 megawatt, you know, engines or turbines, going N plus one, N plus two is another way that projects, um, resiliency projects get overbuilt, just out of just lack of information.
Hmm. Okay, one more question before we go over to the audience. What's the biggest misconception out there about resilience? Davis, you want to start?
Sure, I'd say we actually already talked about it, which is simply that, resilience does not have a payback on its own. Some customers just fundamentally are not quite there when they talk about resilience. It is very difficult for a resilience only project to have a payback and understanding that, there is just inherent value in having higher uptime, keeping your operations running. Some customers get it, but a lot of them don't, and that would be great if more customers understood that intuitively, that it's just going to cost something to get that resilience.
Yeah, I'd say, the misconception is very similar to what Davis said. Resilience is no longer a cost. With the technologies coming out today, the most resilient asset and the most economical or upside asset are the same thing. So the asset that is, providing value day in, day out at your facility is also mitigating your downside. And so you're not paying for resilience. Resilience is rather a dividend of selecting the right asset. And so my recommendation would be, you know, just start treating resilience as, a byproduct of owning your own power and selecting the correct asset.
Yeah, absolutely. On-site power is creates options for for revenue, not just a cost of doing business. And more, it's almost assumed that you have some type of resiliency, when you're talking to, your customers are assuming that you're going to be able to produce, on time and ship on time and have resilient systems in place to assure that you're going to meet your contracts.
Okay, thank you so much. Great. Let's go over to our audience that has some questions waiting for us. The first one is from Salim Rahimtullah, and the question is decarbonization a requirement for your customers in conjunction with resilience? Do you want to take that, Kevin?
Yeah, it can be. I guess the answer is it depends, but it is not uncommon for customers to have carbon reduction goals in mind. And even with natural gas right now, sometimes it's just having a discussion with the customer about site versus source emissions and looking at what's the carbon content of the grid in your area compared to what what your emissions would look like with on-site power generation.
Yeah, I'll add some color there too. As a low emission system, we get asked about emissions in every single customer discussion we have. And what I'll say is it's more centered around the criteria pollutants, whether it's like NOx, CO, PM. But it's definitely very much an important part of, the overall project story for our customers. Now, one thing that's interesting that we're seeing, and this is primarily in the data center industry, is the data center industry is in this huge AI race right now. And, we actually got some feedback recently from a high ranking executive at a hyperscaler. And he basically said, we will win the AI race no matter what, even if it means sacrificing things like our decarbonization goals, which was pretty surprising for us to hear because, they're clearly very heavily regulated and things like that. But it shows that, kind of like Kevin said, it can be a priority, but for some companies, it may not be. All I can tell you is that we do hear or we get asked about emissions in every single conversation.
Is that true for you too, Davis? Is that frequently part of the conversation?
Yeah, I would say it's less part of the conversation. I would say that the tenor of ours is actually similar to what Jake said, and this is pretty blunt statement, one that I felt reflected, particularly in the data center industry, that between speed and competition, the on-site power generation needs that the customers have are pushing them towards natural gas and kind of without any consideration most of the time for the on-site generation producing carbon. So for us, what that's meant is, I may have mentioned this, like we're part of the sustainability group within Siemens, and Siemens has strong sustainability goals as a company, and we embed those into the products that we make. And for me, that also means we try to focus on those types of projects. So doing projects with solar, with battery storage, with low carbon generation is a priority for us, and we're not really looking at projects that are like primarily natural gas centric power plants. Like we're looking for projects that do include that component of we really are concerned and are still thinking about carbon reduction.
Yeah, very interesting issue. So we've got another question here. On-grid to off-grid seamless transition and grid-forming inverters are basic technologies to ensure flexibility and resiliency. Could you refer to their importance? Being able to transition from on-grid operation to off-grid operation in case of grid disturbances is key for the future of microgrids, future-based microgrids. And this is from Alfonso Arias Perez.
I can try and tackle that one because I totally agree. Yeah, grid forming inverters are pretty much, I would say, the standard. Like any battery inverter, or I'm not sure, Jake, we haven't talked too much about your technology if it does include an inverter. But okay, so other fuel cell technologies though that are inverter based, they produce DC energy and need to turn that into AC energy. That's what an inverter does.
We're the same. Yep.
Yeah, the grid forming capability is totally vital. If you need to island from the grid, which is to say, right, you've separated from the utility, you need the grid forming. It's exactly what it sounds like to produce the stabilizing features of a grid locally, just within that microgrid. And yeah, basically, I agree with the question asker that grid forming inverters are absolutely the standard. And I think there's a lot of momentum there. If companies are not producing grid forming inverters, that they and pretty much that's a requirement and totally central to microgrid technology.
Yeah, I'll add on to that. It's also important to understand what what the customer is running off of that grid during that period. And the inverters are important, and also battery design, battery storage, as well as any type of recip or linear generator that's there as well. So you have some rotating mass to help absorb load swings. It's the devil's in the details, and you really have to get down in the weeds to really examine what's going to be expected of that microgrid when the grid goes away, because that's when it really counts.
Okay, good. So now we have a question from Dan Bernhardt. What's the supply chain order to delivery challenges for each of the products with the AI data center push? What timeline can a customer expect on their designs for delivery? Do you want to start with that one, Kevin?
Yeah, sure. I'll happy to go first. And again, it's going to depend on the project. We're doing a lot of EPC work where we'll do basically like a turnkey installation, like my background picture is a project that's indicative of one of our EPC projects, and we try to have enough equipment in our queue to avoid like the new lead time for some of the big turbines or recips can be 2 or 3 years for new orders. So we try to shorten that period by having equipment already in the queue and in production. And we're doing EPC contracts from signature to power online in about 18 months. So permitting is a key part of that too, and yeah, air permits and construction permits lead chew up a fair amount of that time. So it's important to have a conversation with whoever's developing the project to ask those detailed questions, because lead time on equipment is only part of the equation. Getting your air permit is the more important, because that's gonna be the kind of the starting point of when you're able to break ground and start moving dirt and pouring concrete to make the job get going.
I just saw a recent headline that said the air permit is the new bottleneck. So
Well,
I
there you
haven't
go.
read the article yet, but
Noise too.
Yeah. Well,
noise.
yeah, the noise, the air permit is part of it. Yeah, noise is a growing concern. Also, fuel contracts, as more and more outside power generation gets installed. Um, Natural gas that we've all, again, in the Midwest, it's cheap, plentiful, it's all around us, but in other parts of the US it isn't. And there's areas where the pipeline can only push so much gas and only has so much available. So there's parts of the US that are constrained by gas availability as well.
Yeah,
Jake, what?
noise is such a big issue. We've
Yeah.
had a data center company tell us, don't even bring your fans. Connect into our cooling system, which we've designed for noise already, since fans are the loudest noise in our system. And so, we would just integrate directly with the cooling on site rather than bringing our own cooling. And so, yeah, a huge permitting issue and getting a lot of pushback from local communities.
Yeah, agree.
I feel like we could do a whole panel on just that issue. What's happening right now with communities and data centers and how energy can play into it, right? I feel like the energy industry has been at this for a long time. It kind of understands what customers need and what problems you might run into in a community, and sometimes has some tools, as you've described, to help overcome them. Yeah, it's a big topic. So we have 1 minute left, and I want to give the floor to Davis if you want to take that timeline question.
Oh, I deliberately didn't speak up because our timelines are ever changing. It cannot be tested for more than a week, and it totally depends on the technology you're talking about, the delivery voltage and quantities. So it is a challenge that is a huge part of my job to navigate with customers, both internal equipment, external equipment. But there's no number I could tell the question asker because it is so site dependent and again voltage dependent, exactly what equipment you're talking about. But the lead times also change dramatically because we'll have a customer, hyperscalers in particular come in and they'll want to buy up the entire factory capacity for months.
For a
And
year.
suddenly the lead time, yeah, right, the lead time will go from 50 weeks to 80 weeks. And that's just kind of the reality. And so then, procurement goes and we look for additional suppliers and, can we build out this factory some more? Can we, trim some efficiency out? And Yeah, so there's a whole this keeps us very busy for sure.
Yeah, back to the speed issue, right, that we talked about earlier.
Mhm.
Yep.
Well, I want to thank you, Jake, Davis, Kevin. You have been a tremendous wealth of information. I appreciate you being here today. I want to thank this incredible audience for their questions and their attention, and especially thank Xendee for giving us this great platform to get this knowledge out there. So thank you all.
Thanks for having me.
Yeah, thanks for having me.
Thanks for moderating.